Just a brief introduction by me, and then the colleagues will go deep in details about the argumentation, the hydrogen. I'm almost unfortunately, 50 years old, and when the Saudi oil minister said these words, I was a little child in the end of 70s, and he said that talking about hydrogen, the Stone Age didn't not end for lack of stone, and the oil age will end long before the world runs out of oil. He was seeing a future, a bright future. Is it necessary the microphone? Okay, sorry. Can you hear me? Is it better? Okay. He was imagining a future, a bright future of hydrogen, where the hydrogen was used for energy and for mobility. End of 70s, so almost 50 years ago. So what happened? 50 years are passed, and the result is the one that you can see from this graph. The worldwide temperature is increasing, is rising up, CO2 emission as well, and we are here to talk about energy transition, so how to leave the fossil fuel, and we talk about sustainable mobility. So the question remains the same. Can the hydrogen help us in this transition? And we are still blocked at that point. No change practically. So I kindly invite you to take your mobile and type www.menti.com, please. Do it now. Okay. You can type this code, please. I promise these are the last two questions that I do. Sorry. Can you answer to this question, please? Okay. Cos'è questo? Okay, so I think that everyone agrees that it's mandatory to move to a green future. Climate change, okay, is the most selected word, but it's nice to see even independence, I suppose, from the power sources. Nice. Equality and the pollution. Okay, so this is clear. So now we move to a second question. So we keep this slide for it, and we will discuss it at the end. While it's pretty clear that we have to move to the transition, now we see, what do you think about the hydrogen? Be honest, please. Oh, far future. I like it. Explosive, reactive. Clean, powerful. Okay, thank you very much. So we keep these words and we are going to use for the next steps in the end of our presentation. Thank you very much. Really interesting. So now we step back to the presentation. And I put in this slide the Facebook of a magazine. It's a specific magazine used by Technical Gases Company. I have here one of our competitors. So he knows this magazine. And the last month, the magazine dedicated this issue to the hydrogen with the question, the key to unlocking the sustainable future. This is a good question, and I'm sorry, but I don't have the answer. So we can discuss together. I can show you our vision, but there is a unique answer to this question. So before to go in detail, let me introduce who we are. So we work for a group which is present all over Europe, North Africa, China, India, and South America. We have a turnover which is 1.4 billion, almost, and almost 6,000 people. Each year we invest more than 130 million euro in new plants and technologies. What do we do? We work in different sectors. First of all, the industrial sector. So we produce technical gases like nitrogen, oxygen, liquid, argon. We sell helium. We produce hydrogen, and so on. These gases are used for several different production, beginning from food till the healthcare. Healthcare sector it is a very important sector for us. We produce medical gases, and we make the plants that you can see in the hospital to distribute the medical gases. Then we have a biotechnology sector and energy sector, renewable energy sector. We have a sustainable report. We have a strategy on sustainability. And since 2009, we have decided to write down our strategy in a document which is available. It's public, so I invite you to download this document. It's a very clear document where we explain our strategy and where we explain what we have done. The thing that I like it is that we measure our performance. So there are clear numbers that measure year by year our performance. What we have done in the years, as I told you, we work in the renewable energy, we work for low carbon products and sustainable solution for our customer. Our history about the renewable energy began more than 20 years ago with the hydropower plants. So we decided to build up or renew very old hydropower plants to supply our production. Then the second step was the photovoltaic, and in the last year, even the wind farm, connecting again with our production, especially in India. And then we have the PPA, the power purchase agreement. So we buy renewable energy in order to cover each year higher and higher quota of our consumption. Then we work on the biomethane, biogas and biomethane. we have begun a lot of years ago with plans in order to upgrade the biogas, and we are active in the market of bio-LNG. The bio-LNG is used for mainly for trucks, so for heavy mobility, and of course hydrogen. What we are presenting here, it's called merchant. So the hydrogen market is divided in two different parts. The mainly part is the captive, I mean, very large production that are used immediately from the consumer, like a refinery, the ammonia producer, and so on. The technical gas company make another job, the merchant. So we distribute the hydrogen. So this is the scheme of our production. There is a main production plant, a pipeline where we deliver the hydrogen to the closest customers, and then we have a logistic, a very developed logistic, in order to supply, to bring the hydrogen to our customer by tube trailer or a cylinder. Then there is a third way, which is called on-site. So we make plants able to produce hydrogen directly to the customer facilities. Why we are interested in the future development of hydrogen? Because we can play a very important role. The large production will remain the large production, refinery, ammonia, and so on. But the new utilization of the hydrogen will need a specific logistic, and our companies are specialized in this field. In the years, we have developed different technology for the production, as I told you. The on-site has the advantage to produce the hydrogen directly to the customer, and so in that case, we save all the CO2 emission that we have for the transport, for example. But in the years, we always work in the hydrogen, or to develop the hydrogen as alternative energy vector. In particular way, we began to work on mobility since 2006, where we realized that the first hydrogen fuel station at that time was 200 bar, and the engine of the vehicles used was completely different. So now today we talk about fuel cell cars. In that case, we are talking about combustion engines. Then we developed the liquid refuel station in 2008, and in 2015 the upgrading of the fuel station at 350 bar. Now we are talking today, the new project are for 700 bar. So now I leave the stage to Mauro Senili, that will go deep in the sector of the hydrogen. Thank you very much.
Thank you, Alberto, and good evening to all of you. To try to go more deeper in detail about the application of hydrogen on different sectors, I think we have to do a step back about the CO2 emission and the greenhouse gas emission. And in particular, with this slide, I just put a data that is not updated. It is 2016, but it's still valid, through which we can understand what are the sectors that is more impactant on CO2 emission. And actually, looking on this graph, we can see that industry play a very important role, but also domestic agriculture and transportation has a very big role on CO2 emission and to the climate change of our planet. So trying to think how we can apply hydrogen on these sectors, I just report a very classical slide about the value chain of hydrogen. At the beginning, there is every time the production of hydrogen that, as mentioned before, it's not an energy source, it's just an energy carrier. So we need an energy source that must be renewable if we want to avoid the CO2 emission. And we must produce this hydrogen in a green way. Then we can apply it to a large amount of sector. The most easy and most ready is transport. Probably you already know that there is on the market cars fueled by hydrogen that are available. So you can go in a Toyota shop and buy a Mirai if you have enough money, obviously. But you can do it. And for sure, there are buses for public transport that is running all around the city. For example, I don't know if this information it's known, but in Milan we have 3 hydrogen buses that is running through the city since 2015. So there are vehicles that are ready, they are technically ready to be a suitable solution to decarbonize transport. Then we have industry. But industry in general, it's a term that has no sense because there are specific industries that need hydrogen because they have no alternative. And in particular are all the industry that are using fossil fuel to heat up their production process. Then there is a very huge sector that is still not underdeveloping, that is the power to gas. So the use of hydrogen as a battery to compensate the fluctuation of production of renewable energy. And at the end, not because it's not important, but because it's the most difficult to face is the residential use of fossil fuel. This meaning the heating system of our home that at the moment are burning mainly methane in a very simple equipment, and thinking to change completely that equipment, it's not so easy. But in any case, try to go deeper in detail about 3 of these sectors. We can start with the industry sector, and so facing the hard-to-abate field of application. Hard-to-abate means process, industrial process, that need power to heat up their production process. And at the moment, they are burning mainly natural gas. Just to mention 3 of them, the ceramic production, the steel production, and the glass production. In this case, the electrification, it's not possible at all because the temperature of the process is so high that we cannot think just to use a battery or a resistant. We must find a different fuel to run their burner and reach the same production temperature. On this sector, green hydrogen is actually the only technical alternative that can be put in place. And it's also quite easy to do that because burning hydrogen, it's really simple. Yes, there are some things about the safety because the flame speed of hydrogen is higher than natural gas. So there are safety issues connected to the switch from natural gas to hydrogen, but mainly it's very easy to think. A burner, even without so many modifications, but the same burner used for natural gas that can be, with very few modifications, used in order to burn hydrogen. What is the matter on this field? Why we are not doing that on large scale? Mainly for one reason, that is the economics. And the characteristic of hydrogen, because if you compare the calorific power of hydrogen compared to the natural gas in volume, you have that hydrogen is approximately 30%, as approximately 30% of energy content compared to the natural gas. This means that to substitute 1 normal cubic meter of natural gas, you must use 3 of hydrogen. And at the moment, the cost of hydrogen is higher than the cost of natural gas. This meaning that for the large steel production, large glass production, make this change imply a huge increasing of production cost that will reflect on final cost product. So at the moment, the only issue on this field is the cost of hydrogen. That's the reason why Europe, US, and mainly all the nations developed their program to produce on large scale low-cost hydrogen. Then second field, it's transport. I mentioned before some example. The 4 vehicles that are ready to use hydrogen as fuel are obviously car. As mentioned, you can buy a Toyota Mirai, but also buses, and also train and trucks. About car, it's quite easy to understand why it is applicable. We must be clear, hydrogen is not the solution for all the car and the mobility, the private mobility. In particular, if we think about small range and city car, most probably the electrification is the most suitable solution. But if we are speaking about long range car with autonomy that must be 600 or 700 kilometers, at the moment, hydrogen is the only cost-effective alternative compared to the battery. Speaking about buses, in Milan, you can see 3 buses of hydrogen, fueled by hydrogen, and a lot of buses that are fueled by electricity with battery. And in Milan, the 2 technology can be competitive. We must say that an electric bus can transport approximately 20% people less than an hydrogen buses. Why this? Because the weight of the battery decrease the weight, the gross weight that can be, and so the number of people that can enter in the buses. Same thinking about the truck. Truck must have a characteristic that is the most important one, that is the amount of stuff that can be loaded on the truck. If you use this amount of material to load the battery to give autonomy to the truck, you will lose amount of other stuff that you can move around. For that reason, the truck fueled by hydrogen is a suitable solution, and more or less all the truck manufacturers are going to present on the market within this and then in the next year their own hydrogen truck. Exactly because if we are thinking about 1,500 kilometers of autonomy, the electric truck will lose so much transport capacity that will lose the sense of these vehicles. Train is another application that it's going to be implemented also in Lombardia and in particular in Brescia, in which Trenord is changing their diesel train, substituting it with the hydrogen train, and should be 14, if I remember, 14 train that will be delivered in the next few years. Why they took this decision? I have to be clear, hydrogen train, it's not an alternative to the electric train. If we are speaking about Italo or Trenitalia with the long distance and the electrified railway, hydrogen, it's not an alternative. Hydrogen is an alternative on that railway that has not so much passenger and in which it's not cost effective to electrify the line. For that reason, decarbonizing that line that are at the moment fueled by diesel, hydrogen is the only real choice that can be taken. Last application that is the key of hydrogen economy, it's the power to gas. The main aim of each government, of each society, is to increase the amount of renewable energy in our grid. This implies a lot of problems in terms of balance of the network and availability of power. In particular, if we are thinking about photovoltaic, you know, photovoltaic produce energy just during the day, but a lot of consumption of energy happens during the night. Then you cannot think a society that run and produce stuff only when there is sun or wind. So the network manager have to implement the system to balance and compensate this fluctuation. And hydrogen is a very easy way to convert electricity into hydrogen, obviously, and then obtain back electricity. From the engineering point of view, it's not efficient, obviously, but compared to the fact that the alternative is a battery that has a lot of material not available in Europe and a lot of very high cost, hydrogen, even if the yield is not so high, it's a very suitable solution. And then in particular, there are another aspect of hydrogen that it's very important on this field, that is that we can burn it in a turbine exactly as we are doing for natural gas. And for that reason, I just put this scheme of a project in Canada in which it's not green hydrogen, it's blue. So the hydrogen is produced by natural gas, but there are the carbon capture and storage plant. This hydrogen is stored in liquid form, very huge amount, and is used as feedstock for final user, but also in a gas turbine to produce the electricity for the society. And this is, it's a gas turbine that is under realizing in Florence at the moment, and it is the first at the world. It's not made by Sol, just to be clear, obviously. We are collaborating to the producer of this turbine, and it is the first gas turbine that will be installed in a plant to produce electricity burning hydrogen. Just a mention about the way of produce hydrogen, green hydrogen in particular. If we are speaking about renewable electricity, we must speak about electrolyzer. Electrolyzer can be alkaline, very old technology. Let me say that Sol installed some electrolyzer, the first electrolyzer approximately 50 years ago. So very old and consolidated technology, as quite low efficient and use an alkaline electrolyzer that is an issue for the materials of the plant. The most innovative one that is the PAM electrolyzer. I say innovative, but it's another consolidated technology. There are very big plants that use this technology. In this case, we have an increasing of the efficiency, and there is no the liquid electrolyzer. This increase the reliability of the plant. The third family of electrolyzer, it's the alkaline electrolyte membrane. It is, let me call it, halfway between alkaline and PAM. It's a very early stage of developing, but it is very promising. With this slide, I will leave the stage to Elisa, that will speak about the national and the region developing of hydrogen.
So here there is my part of presentation that is related to the macroeconomic context and forecasting demand, so basing on hydrogen for the future. Here I start with the global hydrogen demand, especially related to 3 years, so basically from 2019 to 2021, where we suppose we have a global hydrogen demand that was in megatons per year. In 2021, about 94 million tons, and it is especially divided into the refining and industrial sector. For the refining, approximately the 30%, while industry is more or less the 60%. And here we can see that the hydrogen demand is divided also into different countries, among which we can recognize Europe, where the hydrogen demand is approximately 8.5 million tons. especially the sectors in which we are considering are refining for the ammonia production and the methanol production, and also industry are especially the oil and gas industry, the chemical industry, and the metallurgical industries. Then in 2021, we can merely see a part that is related to the heavy industrial sector, the transportation sector, and power generation, and the residential sectors that are related to a really small part that is more or less the 0.04%. Speaking about Europe, we can see the hydrogen demand in Europe, especially in the 2020, where we can see again here the hydrogen demand in kilotons, here divided by application. So what we can see is that the percentage that we refer to are basically the same we have described before. So more or less the 50% is related to refining, while the other percentage is related to the ammonia production and the methanol production, so basically industrial sectors. And then we have a small part that is related to the energy sector and transportation. On the right-hand side of the slide, we can see the hydrogen demand divided by country. So basically countries within Europe where we can have a focus on Italy, where the hydrogen consumption is about 6%, so more or less 500,000 tons per year, where the main applications reflects the application described before, so basically the ammonia production and the hydrocracking and refining in order to obtain light hydrocarbons. Here we have a slide that is basically a continue of the first slide I presented. So we have a focus not only to the 2021, but also an outlook to 2030 in the future, where we can see two different scenarios, the STEP scenarios and the APS scenario. The first one is the case-based, but now we have to deal with the second one, so the APS. Since it is related to a condition in which all the statement about the transition from a gray hydrogen into green hydrogen are taking place. And so here we can see that the quantity of hydrogen that in 2021 was about 94 million tons, now is will become 130 million tons, with a slightly difference with the STEP scenario, in which we do not consider the sectors that I have announced before, so basically the heavy industrial sector, transportation, power generation, and residential sectors, then that with green hydrogen are becoming, are increasing. Then, talking about Europe, we have to understand what is the concept of energy transition, and especially energy transition is the condition in which we can describe the passage from what is considered the energy source derived by non-renewable energies. So, for example, fossil fuels like coal or oil, to a transition in which we are considering the renewable energies. And this is feasible with the Next Generation Europe, and in particular with the Green Deal. While we can say that the advantages for renewable energies are quite clear, we can for sure underline some critical issues related to renewable energies. For example, the electricity of the sources. So for sure we have to consider the electrification scenarios, but there are sectors in which electrification is really difficult, and so the strategy, so the Next Generation Europe and the Green Deal promotes also clean fuels, among which we can consider hydrogen. And it is here where the hydrogen strategy is set, and it's here where hydrogen can support the decarbonization of industry, in particular in difficult sectors, for example, transportation, power generation, and the residential sector across Europe. So the aim is to reach in 2050 the 24% of the final energy demand with hydrogen, especially seeing that the hydrogen demand, the potential hydrogen demand for hydrogen will be approximately 7 times the existing industry feedstock that we have today. The most important sectors in which we can divide the demand of hydrogen in 2050 will be the power generation sectors, the transportation, residential sector, the industry energy, and the new industry feedstock, where for industry energy we can consider the transition from the use of gray hydrogen into green hydrogen, while the new industry feedstock is where we can consider the direct reduction of iron with the use of hydrogen instead of carbon. Here there is a focus on the state-of-the-art of national hydrogen strategies. In fact, there are on the right-hand side of the slide, there is a map in which we can evaluate which are the countries in which the national strategies are already published and in which countries instead the national strategies are in preparation. In fact, we made a focus on 4 different countries, among which there is India, where the plan is to achieve neutrality in 2070, especially based on clean hydrogen. And instead, there is another country that is the United States of America, in which we have that the national clean hydrogen strategy is still a draft. But the idea is to consider 15 million metric tons per year of clean hydrogen by 2050. Then there is China, where we have a plan for the medium-long term for the investment of the market of hydrogen. And also in the short term, the goal is to produce 200 kilotons of hydrogen by 2025. And at least we have Japan, where there is already a strategy that is called the Basic Hydrogen Strategies in 2017, that undergone a change in 2021, since before the goal was to produce 2 million tons per year by 2030, while now, as it's written here, we have the goal to produce 3 million tons per year in 2030 in order to achieve the goal of reaching 20 million tons per year by 2050. Among the countries just described, there is India, in which the Sol Group is present, and it's present with Sol India, that is a society in which we produce technical gases. Then there is the greenhouse plant, where there is a separation unit that is completely fed by green electricity, so electricity by renewable energy, especially with solar panels and the wind farm. And then there is Boruca, where we produce ultra high pure gases and also pure specialty gases. Then there are advanced and tailored non-gas technologies for the gases generation for the customer's need. In particular, we developed the slide basing on the National Green Hydrogen Mission, that is still not yet a strategy, but also India has the aim of becoming energy independent by 2047 with a net zero mission by 2070. The idea here is to present a graph that is on the right-hand side of the slide, in which we can see that by 2030, the aim is to more or less have the same percentage that reflects the slide just presented. So again, about the 50% of the use of hydrogen in the ammonia production and in the methanol production. But if we have a look also in the future, so basically to 2050, we can see that there is an increase of the use of hydrogen also in the power generation sectors, but especially in the steel industry and also in the transportation sector. Coming back to Europe, we can also cite the state-of-art on hydrogen strategies in Europe. Especially, it is divided into 3 steps. The first one goes from 2020 to 2024, where there is the installation of at least 6 gigawatt of electrolyzers, where the production of renewable hydrogen is approximately to 1 million tons. Then the second step is the one that goes from 2025 to 2030, where hydrogen is becoming an indispensable part of the energy system with the introduction of 40 gigawatt of renewable hydrogen electrolyzers and the production of 10 million tons of renewable hydrogen. The third step is related to the last 20 years until 2050, where the renewable hydrogen technologies has to reach maturity, and especially at least 1/3 of electricity has to be used in order to produce hydrogen. In the left-hand side of the slide, we can see the targets that each country within Europe has set. And in particular, we can see in the second column that there is an essential difference within the conversion among the gigawatt and the quantity of hydrogen, since each country has decided its strategy in order to produce hydrogen in 2 different ways. The second step that I have just presented has been subjected to a change with the REPower EU plan in 2022, since the capacity of electrolyzers installed was 40 gigawatt with the plan described before, while now is 65 gigawatt by 2030. And in particular, the amount of million tons of hydrogen that has to be produced will be doubled. In particular, we have the 10 million tons of internal renewable hydrogen production and also 10 million tons of imported renewable hydrogen production by 2030. In particular, Italy has not yet a national hydrogen strategy, but what we can read is within a guideline that was published in November 2020, and the installed capacity of electrolysis that was set is about 5 gigawatt by 2030. So there are measures in order to support the transition in Italy about the promotion to the production, distribution, and also the use of hydrogen that are present and are the goals within the National Recovery and Resilience Plan that is basically divided into mission components, types, and intervention, where we have that there are 2 different types in order to develop structures for the hydrogen production that are basically reforms and investments. Reforms are more related to legislative aspects, while investments are in order to develop the real structures for hydrogen. In particular, investments are divided into different interventions that are basically the one already described by my colleague Mauro. So basically the manufacturing in abandoned industrial areas, where that is an intervention that that expired in February 2023. Then we have also the use in hard-to-abate sectors, the hydrogen filling station for both road transportation and rail transportation. Then at last, we have also an investment that is more related to university sectors, so the research and development of hydrogen. Now I leave again the stage to Mauro.
as end of the presentation, I would like just to talk about one specific part of the developing of hydrogen. As mentioned, a lot of time you can buy a Toyota Mirai, but you can refill it because at the moment the hydrogen refilling stations are just a few. So the first action that Italy put in place was using the PNR program to financing the realization of hydrogen refilling station within the nation. The situation at 2033 was just 6 hydrogen refilling stations on Italy, and with that action, Italy is going to realize 35, brand new hydrogen refilling stations. And one of the 6 that are installed at the moment has been realized by Sol. I just spent few words about this hydrogen refilling station that has been realized in Capo d'Orlando. First of all, because I was involved in the project, so I'm quite proud of it. And
because there is the competitor.
Exactly. Then even because it's not an hydrogen refilling station, it's not just an hydrogen refilling station, it is an hydrogen refilling station that we realized in collaboration with the CNR, Messina site, and it is something like a laboratory for the smart grid. So it has the integration of different stuff, the energy production, the hydrogen storage, the hydrogen filling station, and also the producing of electricity using hydrogen through a fuel cell. In particular, we realize the electrolyzer, so the production on site, the hydrogen storage, the compressor to realize the refilling of hydrogen and the storage of hydrogen, and also the dispenser. But if you think about this hydrogen refilling station in a smart grid, you can think that you have the renewable energy that can be used directly to produce hydrogen when there is the excess of renewable hydrogen. The other way, the excess of renewable electricity. The other way of using that electricity is the electric mobility, but hydrogen, once has been produced, can be integrated by additional hydrogen produced by biomass, biomethane or biogas, and used both to fuel vehicles, fuel cell electric vehicles, but also a fuel cell to compensate the lack of renewable electricity. So this scheme is a very small realization. It's like a pilot plant, it's a prototype, but as a different brick that create a system that is the example of how hydrogen can be integrated in a smart grid and in our society. The second hydrogen refilling station I will mention, it's just the one that will realize using the PNR program, and in particular one of the 35 that has been elected as suitable for financing, and it is our project in Aosta. Aosta, you know, Aosta is in the mountain, and they had the need to decarbonize their public transport, and they try to study the experience of Bolzano, that is another site in which there is an hydrogen filling station active. And decarbonizing the public transport in mountain through the electric vehicle, it's not possible. Mainly for 2 reasons. For the geographical conformation of the territory, with the slope that increase the consumption of electricity in a fuel cell, in an electric buses, but also because of the temperature. Since it is mountain, during winter it's pretty cold, obviously, and the storage capacity of the battery decrease a lot. So the autonomy of an electric bus in mountain decrease approximately 40% compared to the declared autonomy. For that reason, electric buses in mountain are not a good idea. And for that reason, Aosta choose to buy 27 fuel cell electric vehicles, and we define with them the project to realize our hydrogen refilling station that is supposed
Hydrogen.
fuel cell, hydrogen, electric vehicles. The hydrogen refilling station is supposed to supply up to 280 tons per year of hydrogen. That is enough for the buses and additional cars for private people that will have enough money to buy a Toyota. The project will be realized with the region itself, and the company owned by the region that will produce the green hydrogen. Our plant will be composed by a compressor to make the first step of compression from 200 bar to 450. That is the part of hydrogen refilling station suitable for the buses. This hydrogen at 450 bar will be stored in a stationary storage system that is composed by cylinder. And then we have the second step of compression to reach 700 bar. Actually, it will reach 800 bar in order to have enough different pressure to perform the refilling of cars at 700 bar. Even in this case, we have a very small storage unit at 900 bar and the dispenser unit to refill both cars and buses. With this, we are ended our presentation, but I guess it is quite interesting to see your answer to the initial.
So before going to the conclusion of the presentation, and in time that Mauro show us the answer, let me say thank you to Elisa and Mauro for the presentation they prepared in one night, as we can do. And again, to Elisa for the invitation and for the passion that she put in this argument. So I live close to Elisa, and we have a lot of discussion about hydrogen. Okay, so I don't know if you have some question, but before to go to the question, I would like to see the result. And I don't see it. So select the characteristic of the hydrogen, and the main answer was reactive, and then abundant. So it's clear. It is nice that a lot of people say clean, but just few people say it's safe. So this is really interesting. This is a really interesting point of view. And this is one of the main issues that we face when we talk about hydrogen. It's true, it's reactive, it's explosive, and so on, but with the right expertise can be treated. So I told you that we have a well-developed logistic. All the technical gases company used to travel with trucks bringing hydrogen normally during the days, and hopefully we will not heard about the accident, but normally we didn't heard about accident in the hydrogen. Two trailers travel with the 200 bar of hydrogen normally, and it is safe. So it's clear that it is mandatory to have the right expertise. We work on several working groups with the fire brigade, for example, and we discuss about the comparison between hydrogen vehicles and electrical vehicles. And that they are afraid as well about the electrical vehicles, because try to turn off a fire on an electrical vehicle, it is really, really complicated. Then, do you consider the hydrogen as energy carrier, energy source, reactant? It's not an energy source, for sure, okay? It's a way to bring the energy, to keep the energy, and it's a good way, or better, that in the next future we will not have another oil. So we must learn how to use as much as we can renewable energy. And when we have renewable energy, we must be able to storage, and it is a good way, a good carrier of the energy. Which is the best way to transport the hydrogen? This is nice because there's no answer. Okay, you say it in liquid form. It's clear that the higher is the density and the better is the transportation. But today in Italy, we don't have liquid transportation. There's no liquid production. So liquid production, it's a very complicated technology, well known in US. In USA today, 60% of the merchant is transported by liquid, but this is not the reality in Europe, for example. The real answer is that, pipeline and so on. The real answer is that it depends on which is our target. So if we have a short transportation, the best way is the gases, and the longer is the transport, and the better it is the liquid or the green ammonia, but for very high distance.
Alberto, I think that it's because the last event, Professor talked a lot about liquid hydrogen.
Sure. The density of 250 bar, I mean in terms of power, it's 2.5 megajoule per liter. With the gaseous, it becomes 8.6 for liquid and 12.5 with the ammonia. But even the cost to produce it is completely different. So it is a good way to have higher density. We do the same with liquid nitrogen and liquid oxygen. Bring a cylinder, it's more expensive than travel with a trailer with liquid oxygen or nitrogen. We increase the density for sure, but we must compare the technology in order to produce and make liquid hydrogen. It is really expensive, taking consideration that we need almost 10 kilowatt per kilo to liquefy, compared with less than 1 for the nitrogen to liquefy. Okay. What's the most widespread way to produce the hydrogen? And the answer was the steam reformer. Okay, our actual production is gray hydrogen and is done by steam reformer. Steam reformer is a good way for production, for sure. But the main one is from petrol and is used by the refinery on the captive sector. For the merchant, the most used is the natural gas, yes. And unfortunately, we don't use the electrolyzers because it is really expensive, taking consideration that you need more than 5 kilowatt per normal cubic meter of hydrogen produced. And that's the reason why we are not using in a large way the hydrogen. Which of these future uses of green hydrogen do you see most likely? So main one is mobility for the heavy duty, and that's a good answer. And then we have energy buffering, energy network. For sure, as I told you, we will not have a new oil, so we must be able to use the right carrier in the right way, in the best way. Hydrogen is not the solution for everything, but there are some sectors where it's most useful. Mauro told us about train, plane, we talked about even shipment, even if in another form, but I think that it will be most effective in those sectors compared with cars. Every one of us can see that the development of the mobility in the city is the electricity, and it's clear that the reason. For the energy buffering, we must use it even if it's not so performing. So it is not the best way, but if I don't have any alternative to use the hydrogen, we are going to use even to produce again the energy. So the trick is to storage the energy as much as we can and then use this energy in the best way. If I can use the hydrogen as hydrogen for mobility, for chemistry, for feedstock, it's perfect. If I don't have any alternative, I can use it for balance the energy. I trust that one of the larger use in the future will be for feedstock in order to produce green ammonia for sure. In which mobility sectors the use of hydrogen vehicles could be more effective? And we already discussed it. Trucks, train, and plane. That's our vision. I don't know what can happen in the future, but monitoring this sector, I see less possibility for the cars in this moment for sure, and more for the heavy mobility. No one says that it's not be used for the mobility. What will be the most widespread way to produce hydrogen in the future? From renewable energy, of course, sure. So in a future where all the production of the energy produced will be renewable, main of this energy will not be programmable, sorry. And so we have to find a way to storage it, and for sure we will use this renewable energy. As I told you, and as Mauro told you, if you take in consideration that to change, to substitute a cubic of methane, we need roughly 3 cubic of hydrogen, and roughly a cubic of hydrogen is 3 times roughly of a cubic of natural gas, or it was before the war. It's clear that we need a very economic power source, and the only economic power source that we can have is the renewable when I have to waste it. So if I don't have the possibility to use that energy, I can take it for free or something like that and produce a very low price hydrogen. Ok, provo a spostarmi sulle parole. I don't know if you have some question in the meantime.
There's a question.
Yes.
What did you mention that if you want to substitute hydrogen of the natural gas in industry or power plant, we need about more than 3 times. Why the LHC of the natural gas is around one third of the LHC of the hydrogen? I mean, the LHC of the hydrogen is 120, and the LHC of the natural gas, the base assay is 50.
No, I mean, if you use the natural gas to heat up, and if you compare the power that you can take from a cubic of natural gas and a cubic of hydrogen, in order to replace natural gas, you need 3 times the volume of the hydrogen. Okay? And let's talk about cost before the war, because the war has completely changed the cost of the electro energy and the natural gas. But in that time, we had roughly a ratio which is 1 to 3 on the cost of cubic. So it means that before the war, in order to have the same quantity of heat, with the hydrogen, you have to pay almost 10 times. Okay, so that's the difficult. Why we are not using to produce steel and so on. Mauro said us that technologically we are not so far, because it's pretty easy to change a furnace that is working with natural gas with the hydrogen. Yes, we have to analyze materials and so on, but it's not impossible. The main issue is the cost around this kind of production. So up to now, it's not sustainable, economically sustainable.
These are any power plant that the Europe hydrogen or not? No.
No, sorry, say it again.
Now, is there any power plant that use hydrogen for the fuel or not?
Instead of the natural gas or other, no. There are some tests, but in real scale production, there's no any plant that is using the hydrogen for power production.
Could the pipeline of gas that now are used for natural gas be used to transport hydrogen?
Absolutely not. No, I'm joking. It's just a matter of companies. No, can be used. Some test has already done, and it depends on the source of the information. But let's say that for SNAM, for example, we can reach easily 30% of the amount of hydrogen in the net. For the European community, we cannot go over 10%. Tell me if I am wrong. Roughly 5%. Thank you very much. But can be used for sure. The problem is not the net, but the final user. Not all the consumers are ready to use the hydrogen. Oh, sorry.
I just am curious. I didn't know about the couple of station. So I was wondering, is there going to be any other project from the company in the future?
Actually, we are working with CNR because we are implementing the station. We presented project to add also the module to 700 bar, but at the moment nothing has been financed. So we are just working with CNR to keep the hydrogen filling station updated and in operation. Then there are a lot of projects about hydrogen, not made by Soli in Sicily, but a lot of refinery and other plants are thinking to use hydrogen. Sicily, like as a platform for hydrogen, connecting two questions. One of the idea is to use the actual pipeline from North Africa to import gaseous hydrogen, and the pipeline is arriving in Sicily. So the region is thinking to be elected as a hub for hydrogen for Italy and for Europe.
It's clear that this year is the very important year for the hydrogen. So I told you in the beginning that within 50 years nothing happened on hydrogen, but since the beginning of the end of last year, the financing for new projects in large scale has begun. So within a couple of years, we will see a lot of hydrogen production plants, large scale, a lot of fuel station, and so on. So this is the right year where we will see if we will succeed to go on in the hydrogen economy. Up to now, without any financing from the state, from the European community, it's not economically sustainable, the hydrogen, for the reason that I told you. But as we have done with the photovoltaic and so on, the aim is to reach a sustainability even from the economical point of view, developing the technology for sure. Any other question?
I have a question. Maybe it's quite hard, but why other?
Don't do it. See.
No, it's not hard. Why other countries in Europe investing more than Italy in hydrogen?
This is very hard. As a
But I
question.
don't think that they are investing more than Italy. I'm not sure. In the past, yes, but with PNR, I guess that amount of public money on hydrogen, as in Italy, it's not present on Germany, on France, on all the other countries.
It's true that the US are investing more than us, and in a better way, because they decide to sustain the project covering the OPEX, the operative cost, instead the investment. Up to now, all the tools that the European community has developed are focused on the investment, and roughly, if you take in consideration the cost of the hydrogen, roughly 25% is the investment and 75% is the operative cost. So once again, USA has decided later than us, but in a better way to sustain this kind of production for sure. Then there are other continents that are moving slower than us. China, for example, I think it's behind us, that they move very fast, but up to now they haven't yet developed a good economy around the hydrogen. And taking consideration this question, I would like to link with the other slide, because someone, in this one, someone has wrote independence, and this is a topic really important, because Europe has the opportunity to be more independent from other continents with the hydrogen economy. We have a very well developed technology for production, the hydrogen, in terms of electrolyzers and for the final usage. So it is an opportunity to be more independent. I hope that we will be able to take this opportunity. Any other question? Can we go to watch the match? Ok. Ok.
Sì.
Dove fai sull'altra? Sull'altra, esatto. So, I close with these words. It's nice to see very big, clean water. I don't understand cold. Who's wrote cold? Okay, sorry. Very, very cold. And but I see very big, even explosive, energy storage, lightweight, opportunity. I like it. It's an opportunity for sure, and we will see if we will have the ability to develop it. So, thank you very much.
Okay, so I really thank Sol Group for coming and explaining all their projects. I think it was really interesting. And well, in conclusion, I hope you enjoyed these two events. If you have other questions, you can just contact us. And I have left here some booklets that we have written as Resilient Gap. And there's also a very big QR code that you can scan and follow us and look about what we are doing during the year, I mean. So thanks for coming and goodbye.